going to have questions after each one, so Dan is going to open us up here and talk about the Galactic Bulge Time Domain Survey.
Thanks, Lee. Okay, so I will give an update on behalf of the Galactic Bulge Time Domain Survey Definition Committee. As Lee said, we've been hard at work for the better part of this year to define what will hopefully be a diverse and successful core community survey in the Galactic Bulge for Roman. In this talk, I will sort of describe the work that we have been doing and also give you some idea of the concepts and the survey definitions that the committee is leaning towards. I want to stress that it says update in the title, so nothing that I will show today is set in stone, but will hopefully be a good starting point for discussions and feedback from the community, as Lee said, from you all, both this week and further down the road as we move towards the final definitions of the survey in November. So I'm talking on behalf of a large group of people. So Jesse Christensen and I are co-chairing the committee. We have in total 10 community members on the committee spanning a wide range of expertise, from exoplanets to galactic astronomy to extragalactic astronomy. We also have a few folks on the committee who are acting as solar system liaisons, so representing solar system science interests actually on all three of the core community surveys. So as a reminder, and this has been mentioned, of course, already in the earlier session as well, we are all the core community survey definition committees work within the science requirements of the core community surveys, and for the Galactic Bulge Time Domain Survey, that is the requirement of carrying out a statistical census of exoplanets and exoplanet demographics using the microlensing technique. So on the right-hand side here, Jennifer already showed a version of this plot before. It's just as a reminder for those of you who are not familiar with this, the discovery space of Roman in a planet, let's see if this pointer works, planet mass versus 7 major axis plot showing that the Roman discovery space really nicely complements the planets that have been discovered by Kepler by probing lower mass planets on much wider 7 major axes. And so, should I stop? Yes, no. Okay. And so, as a reminder, the Galactic Bulge Time Domain Survey has, of course, undergone already some iterations and some concepts. And as a base concept, we'll call it the reference survey, we can take, for example, the survey that has been outlined by Matt Penny's paper in 2019. So as a reminder, what the plan is that Roman will observe 7 fields near the Galactic Bulge, as shown here on the left, and it will hop between those fields, observe one field after the other, and observe them for a certain amount of time. 72 days will be the maximum, or approximately the maximum duration that can be done. And as a function, as it hops around the 7 fields, the cadence will approximately be 15 minutes. So this was the cadence or the simulation parameters that were in the Penny et al. 2019 paper. 72-day observing seasons, 7 fields over a 2 square degree field of view, yielding a 15-minute cadence. We do this 6 times over 6 seasons, 3 at the start of the Roman mission and 3 at the end of the Roman mission. In addition to the broadband filter high cadence, there are also observations with a narrow filter every 12 hours, and this is important for example, microlensing mass measurements. So those are sort of the reference parameters in this blue box up here, and we, of course, are considering changes to these parameters to accommodate other science that can be done. But of course, we can't change everything drastically. These changes need to be within meeting the science requirements of the exoplanet demographics for microlensing. But to give you some sense of how much we tweak these parameters, how much we can tweak them, I'll give some numbers down here. So the observing seasons can be changed from something like 60 to 72 days. We can change the number of fields we're observing from something like 5 to 9 fields. We can change the observing cadence between something like 7 and 15 minutes. 15 minutes is a pretty hard upper bound. Of course, there's a trade-off between the cadence and the number of fields. Jennifer already pointed that out in an earlier talk. And we, of course, are also discussing changes to the narrowband observations, for example, the cadence of these, increasing them, and also having multiple filters instead of just one narrowband filter. So the input to the discussions that the committee has been having over the last few months, of course, come from the input from the community, from you, and that has been collected by the Roman project through white paper calls and science pitch calls. The Galactic Bulge Time Domain Survey has received about 20 white paper submissions, about 40 science pitch submissions. These are the word clouds I think Julia already showed this earlier today. One of the things I want to point out here is that exoplanets, of course, features in these word clouds, but there are lots of other things that feature in these word clouds. And so our charge and our goal is to make sure that a diverse range of science can be done with the Bulge Time Domain Survey, following or including the science requirements that it needs to follow. We had a follow-up call for updates that was sent to white paper authors. So this white paper call was last year. We had a follow-up call for updates earlier this year. So based on this, this is basically what we've been doing. So we've been working through the white papers and the science pitches. Here's a brief sort of timeline. We had a kickoff meeting in February this year. Since then, we've had sort of bi-weekly to weekly meetings, depending on the pressure of what we wanted to get done, about 25 hours of committee meetings since then. In March, we designed and organized a review process of the white papers and the science pitches. We then spent a couple of months actually reviewing the science cases, collecting them into big picture science cases, ranking them. We're now in July, we're here, we're reporting to the community for feedback and iteration, and the later steps, I'll talk about those a little bit later on, of course, all leading up to November, which is when the report will be due. So in the next few slides, I will give you, and for the rest of the talk, I will give you a bit of an idea of some of the ideas that were proposed by the community that the committee is leaning towards or thinking about implementing in draft survey recommendations for the Galactic Bulge Time Domain Survey. One of these ideas, and that has been mentioned in multiple white papers, is the idea to add an additional field, an additional high cadence field at the galactic center. So there are various advantages to doing this, scientific advantages, and opening up a wide range of science that you can do. On the left-hand side is a white paper that pointed out that, of course, the sources, X-ray sources, high-energy sources, so this in particular is showing Chandra X-ray sources, increases as we move to the galactic center. So the green points here are X-ray sources from Chandra. So if you would place a Raman field at the galactic center, you would automatically have a synergy between X-ray sources and energetic events such as X-ray binaries, CVs, that you could study with time domain observations with Raman. There's another important science case, and that is actually studying stellar populations in the galactic center. So the right-hand side plot here shows the stellar density. Sorry, the pointer's a bit off. Stellar density is a function of distance from the galactic center, and showing the different populations, the nuclear star cluster and the nuclear stellar disk, that make up the stellar populations in the galactic center. The footprint of Raman is actually really, really nicely sort of matched to these populations and the spatial extent over which these populations affect or are located in the galactic center. So as a pointer here, Raman, the Raman field of view reaches all the way over here, about 7 times larger than the extent that was covered with HST. And that allows, of course, time domain photometric studies, time domain kinematic studies of stellar populations in the galaxy. There are lots of other additional science cases you can do, stellar compact object binaries, variable stars, transiting exoplanets, that would all be opened up by adding an additional field in the galactic center. Now, another idea for a possible modification is to perform off-season observations. So by that, we mean that the nominal survey has 6 high cadence seasons, right? 3 of them nominally at the beginning of the Raman mission and 3 of them at the end. So 3 at the start of the 5-year mission and 3 at the end. And the suggestion here is that there are 4 additional bulge seasons that we can take observation in, and the suggestion is to return to those, to the bulge, to the same fields with lower cadence observations. The motivation here is that doing so will enable us to sample longer duration events, in particular microlensing events from more massive sources, such as isolated black holes. This is shown here on the left. There's actually will be a talk, I think, by Casey Lamb on Friday about this, basically showing that the microlensing timescales are a factor of 100 longer for isolated black holes. And so we want to avoid a scenario such as the one pointed out here, where you have a microlensing event and you miss it because we have no observations in the gap in between. So this in general, the possible cadences, of course, you can do this in. You can do 1 observation per day. You can do 1 observation every 10 days. The cadence is still being discussed. We haven't really fixed that yet. But in general, this should be a fairly low-cost, high-gain idea that we can add to the survey definition. The other case that's made in many white papers is, of course, faster cadence. And Jennifer already made this point already earlier today in a talk. Everyone wants faster cadence, and that is good for microlensing, but it's also good for other science cases, including transiting exoplanets. Robbie Wilson will be giving a talk about this tomorrow. On the left, showing the transiting exoplanet yield as a function of cadence, and showing that especially for the small planets, so sub-Neptune-sized planets, the yield goes up if you have a shorter cadence. It also is good for astroseismology of red giants. So this is a plot from Noah Downing's poster on the right showing a cadence of 15 minutes. So these are power spectra of simulated Roman time series. And here's the power axis due to oscillations in 2 stars with 15-minute cadence. And if you do 7.5-minute cadence, the signal goes up. This is important because especially the astroseismology of red giants is really sort of red clump stars is really at the detection limit. And Mark Pinsonow will talk about this a little bit later tomorrow as well. So cadence, faster cadence is good, but of course also there's a lot of white papers that advocate for more fields, and you can't have both, right? So it's either faster cadence or more fields, but if we want faster cadence, we need less fields. So a possible variation that we've been considering is to perhaps observe 1 field at twice the cadence in exchange for observing 2 fields, at half the cadence. So this would be sort of an in-between scenario where you don't switch the cadence for all the fields and just half your fields, but have an in-between scenario that might enable some of these science cases to go forward. Okay, so just a little bit more on the trade-offs between cadence, number of fields, and exposure time. These are simulations by Matt Penny showing why this is important and how this can affect the survey design. So these are field layouts of the galactic bulge time domain survey. On the left-hand side here, this is sort of the regular 7-field contiguous arrangement that you've seen before with the updated slew and settle time that gives a cadence of about 12 minutes. The second one on the left is 9 contiguous fields. If you add more fields, your cadence will go up, of course. So we have 15-minute cadence. The second on the right is 7 contiguous fields plus the galactic center. If you do this, you get a cadence of about 14 minutes. And on the very right is 7 contiguous fields plus the Earth transit zone, which we heard about just in the last session. And in that case, you get, because of the longer slew time, something like 17 minutes cadence. So there's a trade-off, and some of the fields that require long slew times may become prohibitively expensive just because we need to have a certain cadence to fulfill the level 1 requirements for microlensing. And maybe better suited for general astrophysics programs. So in particular, I think 2 additional fields in addition to the microlensing fields would be something that's very hard to realize. Okay, some other ideas, just to wrap up, that have been considered, and these come from science pitches and also considerations within the committee, is to perform more multi-band photometry and perhaps even spectroscopy of the microlensing field. So this is the idea of not just doing time series observations in 1 or 2 of the narrowband filters, but all of the narrowband filters. So you could take, an image of all the microlensing fields in all of the filters that Roman has available that allows stellar characterization for color measurements. You can go even further, of course, and take spectroscopy with the GRISM, so low-resolution spectroscopy of the microlensing fields. There's variations to this. We could do this only once at the very beginning. We could do it once every season at the start and at the end. Or we could even do it with low cadence throughout the seasons. So this is basically adding more wavelength information for rare science cases that would benefit from this. Okay, so I want to wrap up with just showing you a sort of straw design of how the galactic bulge time domain survey could look like. We are given by the Roman project guidelines for the total survey duration. So the nominal survey duration is 420 days. The underguide is 380 days, and the overguide is 440 days. And so a possible scenario, and I'll emphasize that this is preliminary, is that we could, for example, in the nominal survey, do something like 6 times 70-day observations of the microlensing fields, including the galactic center. That's assuming that adding the galactic center will still allow us to achieve the level 1 requirements for the exoplanet demographic science case, and then do low-cost additional things such as take an image of all the microlensing fields in all the filters and take a spectrum. For the underguide case, we would of course have to be more conservative. The seasons will have to be shorter, something like 6 times 63 days with contiguous fields only, right? Because it's shorter season duration. So in order to achieve the exoplanet demographics goals, we probably won't be able to add the galactic center, but we could still do things like taking an image of all the fields in all the filters. And the overguide, we could do a lot, right? We could do the seasons as long as we can, 6 times 72 days, do photometry, do spectroscopy, do the off-season observations that I've talked about. And another idea, which I haven't had time to go into, is to perform very high cadence observations of a single field. So 1-minute cadence observations of one field, perhaps also in each season. Again, this is preliminary. All of this still needs to be simulated, in particular, the impact of these designs on the microlensing yields. Okay, this is my last slide. So the next steps for the committee are to refine the sort of studies that we've done, the trade studies, investigations, simulations, to make sure that the level 1 requirements are still met, and develop nominal implementation plans. We do plan in October to have another update for the community, sort of have a preview of the survey definitions to the community for feedback, and then in November, the report by the committee with the survey draft, with the survey implementations, nominal, underguide, and overguide will be due. We'd love to hear your thoughts on all of this. There's several venues to do this, both of course here in person. We will have a dedicated, we call it office hours. Tomorrow, during the lunch break, Jesse Christensen, who's here in the room back there, Jesse, will be organizing this just outside the Baxter Hall. So maybe we'll do another announcement tomorrow just to remind people. So this will be committee members being there to have any sort of input you might have on the on what we presented today, or any questions that you might have. And we also plan to give an update for folks online in perhaps one of the Roman community forums. I think Tom mentioned the next opportunity might be later in July, but this is to be confirmed. But basically, there's still time for input, and we'd love to hear your thoughts on the draft survey definitions that we've come up with so far. All right, I'll stop there. Thank you.